Hello, my name is Aaron. Um, I'm head of data services at the Singapore Management University Libraries. Thanks for having me. I'm going to spend the next few minutes talking about my view on how academic search is changing due to AI. I'm sure many of you are very familiar with how the landscape for academic search has been changing ever since the launch of large language models, more particularly GPT 3.5. And academic search has also changed a lot during these few years. Some of the earlier innovators were startups like Elicit, Consensus, Perplexity, and of course by now it's spread to our academic legacy databases. So there are things like Scopus AI, Primo Research Assistant, Web of Sciences Assistant, and so on and so forth. There is a class of tools that is often discussed in the same area as AI tools, is what I call citation-based literature review tools, right? These tools are generally recommended systems, right? They are not such systems. So like, for example, Research Rabbit, connected papers, these are tools where you generally insert one or two seed papers or relevant papers, and then the system uses some sort of algorithm based on citations, right, to recommend potentially relevant papers. But unlike the tools like Elicit and SciSpace and all the other tools, this set of tools generally currently do not use large language models for recommendations. Um, and they usually are used more for seeing linkages between citations. Though I would say that some tools like Litmaps do have modes that use semantic search. But we talk about traditional academic database searching, right? I think vendors are struggling a little bit on how to describe this set of tools, right? One of the terms that I've seen people use, and I've used it myself, is AI-powered search. And AI-powered search is a good term as an umbrella term, right? But if you want to understand exactly what is AI-powered about the search, this term alone is not very helpful, right? So I propose that when we talk about AI-powered search, we can talk about it in terms of two different ways in which the conventional academic databases have changed. So one way where academic AI-powered search differs from traditional databases is the fact that they go beyond just using Boolean or even just lexical or keyword-based search methods. So we generally talk about things like natural language search, right, which tells you that this type of algorithms, it 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 works fine for keywords, but generally it works better if you type in natural language, right? Closely related is semantic search, right? Semantic search basically is the dream that you may not know the right keyword, but the system, the algorithm is able to understand the intent and the meaning of your query and match it with the meaning of the document. And semantic search, in many cases, they also do well for natural language search. So the two terms are almost synonymous. The latest technology is what we call deep or agentic search, right? So I'll talk more about this later, but essentially when you talk about normal search, it's one shot, right? You type in your search query, it does one search, that's it, right? A deep or agentic search generally goes through many rounds, it's iterative, right? As agentic, right? So many of it will work like the way a researcher does. It will do keyword searching, it will do citation searching, right? It go through many rounds of searching, and it tends to run like maybe 10 minutes, 30 minutes, right? It won't be as fast as like 10 seconds or 5 seconds. And underlying these terms, there are of course technical issues, right? For example, semantic search means search by meaning, but how do you search by meaning, right? And there are a lot of technical terms that librarians may want to try to understand, right? For example, using LMs to query expansion, vector embedding searching, and more advanced techniques like learn, sparse retrieval, and so on and so forth. This set of features that I just mentioned, they only impact retrieval and ranking, right? You could do natural language search, you could do semantic search, you could do agentic search, and the output could still be a set of ranked results, right? The same as you see in Google Scholar, the same as you see in Scopus. But AI-powered search gives you the ability to summarize the top set of results to produce an answer that tries to answer your question with citations. Some people call this an answer engine, right? And again, there are more advanced techniques like deep research, which goes beyond answer engines, and produce full set of reports. And again, if you want to look at the technical part of it, you have to look into retrieval augmented generation, of which there are many variants. And of course, nowadays, the excitement over agentic methods to produce long reports. Right, so I'll talk very briefly about AI search in terms of generation of direct answers for questions. Right, so you see this in things like Primo Research Assistant, where it gives you not just the top ranked results, but also summarizes from the top ranked results. You see it in Site Assistant, you see it in agentic systems like Undermine, Scopus Deep Research, and so on and so forth. There's a lot you can say about it, but one thing you need to understand is retrieval augmented generation, right? So it's not a very complicated concept. The general idea is when you type in a query, the system will actually retrieve. Yeah, you can use any type of retrieval method. You can use Boolean, you can use semantic search, right? You can do deep search, right? It generates a set of queries, right? And you'll find a set of top results, and the top results will be fed to a language model, like a GPT model, and you'll be given a prompt. So there'll be a built-in prompt, right? So behind the scenes, the prompt might be something like answer the question below using the information found from the information found in what was retrieved, right? So you will put in maybe title abstract of the top ranked results, and the system will be prompted to try to answer the question, right? Using what was found, and it will be prompted to kind of cite what was found, right? That's how you get a generated answer, right? And retrieval augmented generation I think the term was first coined in 2020, and there is like there are like hundreds, by now there are hundreds, if not thousands of papers about studying retrieval augmented generation. There are many survey papers, but I think the main issue when it comes to retrieval augmented generation is that in most cases, the citations that it generates will be real citations. The issue more is what we call source faithfulness, right? Which means that even you may read a sentence that's generated, you look at the citation, unfortunately, even though the paper is real, the paper does not actually support what was generated. Right, so this is an example, a very old example that I saw in Site Assistant a couple of years ago when it first launched, right? So it basically said that, oh, there's a consensus in the community that we should not use Google Scholar alone for systematic reviews, and it cites a lot of papers, which is fine. But one particular paper I noticed, I'm familiar with this paper, it actually says the opposite, right? So this paper actually was an outlier. It actually concluded the opposite, that Google Scholar can be used alone for systematic reviews. Right, so this is what I mean by a lack of source faithfulness, right? And this is an issue that still occurs even using the latest deep search technologies. So when we talk about normal retrieval augmented generation, the first generation of retrieval augmented generation systems, they generally would produce 1 or 2 paragraph of answers, right? In around 2024, 2025, the idea of deep research began to emerge, right? So for deep research, right, essentially what you do is that you do a deep search, so you do multiple iterative searching, and then you take back so you get a huge set of results, and then you use deep research to generate a long set of results. Right, so this is OpenAI's, this is Gemini's deep research. It generates a report that's like 8 pages long, right? And obviously, because it's using deep search, it will search for a long time. You'll find maybe like 30, 50 relevant articles, and will generate a full report based on this 30 and 50 references, right? I've written about this whole agent-based deep research tool. There are, of course, the ones that search the web, things like Gemini Deep Research, OpenAI Deep Research, Perplexity Deep Research, right? And there are ones that are searching academic indexes, right? So Undermine, PaperQA2, Sciencebase Deep Review, and of course, we have things, and since then, things like Scopus AI, deep research start to emerge. Consensus has a deep search, right? So this is something that is getting very popular. Um, Again, this is just my view of the quadrants. You can see it as having quick search and deep search, right? And you can pair it against the fact whether it just generates a set of results or it generates an answer, right? So the academic search world generally was moving towards simple rec, what I call quick rec, before it moved to deep research. Right, so this is an interesting survey paper about deep research tools, but generally it gives you an idea of how they all work. So usually you type in a query, there will be some, it will create some sort of plan, and then you'll be asked to decide whether you want to override the plan, right, or to clarify what you are actually looking for before it goes off to do iterative searching, right? And usually it has a lot of tools, right? So you have various retrieval methods, right? A lot of them would even have coding methods, so you could generate tables, figures, and so on and so forth, and generate a whole long report. So I'm quite bullish about deep research for academic search. Not so much for the fact that this deep research can generate full reports. I think they are very useful when they help you map out the lay of the land, right? So the best tools, they focus on helping you understand the area, right? So they may give you, for example, foundational papers. They will tell you what evidence there is for various claims, what has not been done. Um, they may even tell you, what's the best order to read the set of papers, right? So I find this very useful as a guide to quickly get up to speed on areas that you know. Um, Beyond generation of answers, I think another area that I think we don't discuss that much until recently is the fact that we are moving beyond Boolean, right? And this means that we are going to, and this means we actually focus. So in this section, I'm focusing more on how results are being ranked, right? And how they are being retrieved and ranked beyond using Boolean or standard like TF, IDF, or BM25 methods, right? So of course I don't have time to really go deeply into this whole search algorithm area. I do give workshops that last 3 days on this topic, but I'll give you a quick overview on how large language models are being used to change the way retrieval and ranking is being done in academic search. Right. So the most obvious way large language models have been used is to suggest keywords for you to add, right? So this is progress dissertation and thesis global, right? If you turn it on, when you type in any query, it will suggest certain keywords you can use, right? So the LLM is just being used to recommend keywords, right? So this is nothing really very fancy, right? I think I think getting more and more common is the idea of using LLMs to generate Boolean from natural language, right? So like, for example, you type impact on climate change on biodiversity, right? The progress, the natural language search, sorry, the app school natural language search, right? They will ask the LLM to generate like a Boolean search query, right? I don't really know, they don't tell us what the prompt is to the LLM, but it could be something like this, right? You can prompt the LLM, for example, to say that, oh, you are a researcher, please convert your the whatever natural language query into Boolean, right? You can tell it to say identify key concepts, break it down into synonyms, and then add them together, right? So this is very, very similar to how a human would do it, and would generate a Boolean search. And this is very common, right? It's actually used either solely or as a component of things like Scopus AI, Web of Science Research Assistant, uh, Web of Science Smart Search, Primo Summer Research Assistant, Site Assistant, and so on, right? So this is getting very, very popular, but the results are not very good, right? So when you're a librarian, if you look at the Boolean, you realize that it may not be the best, right? So this is something to think about. The other thing that that LMs or large language models are being used is to use it directly for ranking, or directly for ranking and retrieval, right? So for example, instead of like giving it a score based on, say, whether the keywords match, you could theoretically say, okay, run a search, right, and take the top 20, and for each one, you feed it to a large language model with a prompt to say something like, oh, this is the query, and this is the title abstract. Based on this, tell me whether it's partially highly relevant, partially relevant, or marginal, right? So you can see the prompt here is basically saying, take the query, take the title abstract, and then classify, right? And of course, you can do various things besides classifying into relevance classes. You could also ask it to give scores. You could do comparison methods. But basically, you can see the idea, right? This is of course a very, very expensive method, right? So you cannot like let's say you have like 2 million results, you can't possibly 2 million databases, 2 million uh items in your database, you can't obviously run the LLM on all 2 million, right? So you probably need an algorithm in a first step to actually cut down to potentially relevant papers and then use the LLMs for the rest, right? The cool thing about using LLMs to do ranking and retrieval is that you can actually ask the LLM to explain why it thinks a certain result title abstract is relevant or not. Right, so this AI2 paper finder, you can see that it will tell you that, oh, it's the LM thinks it's relevant, and it tells you, it explains why it thinks it's relevant. Right, this undermine shows the same thing. Right, so LM powered re-ranking is extremely powerful. Right, there are various studies, which I don't have time to show you, that shows that it tends to correlate quite strongly with human judgment, around 70 to 80% for even very complicated queries. Right, as I mentioned before, it's extremely expensive, so you can only do it after a first stage retrieval, right? And then the promising ones are being fed to the LLM, right? It's also part of agentic and deep search, right? So when you do agentic and deep search, the LLMs is used to decide when and how to search, and it's also used to do the evaluation to decide whether something is relevant or not. Right, I'll just show you one study. This is from Undermine, which is my favorite academic deep research tool. This was done in 2024, right, using the original GPT-4. And as you can see, right, whenever so they basically ask the human to judge whether a paper is highly relevant or closely relevant or related. And you can see that whenever the human thinks it's highly relevant, Undermine thinks it's highly relevant 75% of the time, and closely related 22% of the time. So if Undermine tells you something is highly relevant and closely related, it will capture 99% of what the human thinks is highly relevant, right? So this is very, very close. It's quite so this shows you how powerful using LLMs are for relevancy classifications, right? And of course, in systematic reviews, they are doing this as well. There are like, I think 20 to 30 papers out there studying this, right, for systematic reviews. So instead of screening using humans, you would screen papers, title abstracts, or even full text using LLMs. And there's a lot of different studies on how to do it properly, what's the right prompt, how to structure it, how to take into account reasoning models, right? And I think this scoping study earlier this year, they actually studied how LMs are being used in systematic reviews. Uh, LMs used for screening is extremely promising. Most of the studies are promising when they're used for screening, but when LMs are used to generate Boolean for search, most of them are not promising, right? So this explains why when you look at, say, Primo Research Assistant and you see the Boolean comes out, often it doesn't look very good, right? So we talked already earlier about agentic deep research, right? It does a deep search, right? Generally what it does is that it will ask you to clarify your intent, right? Is that like what exactly are you looking for before it goes off to start the planning and does an iterative search, right? So it uses tools. So the tools could be like a search engine. It could be using Google Scholar, PubMed, its own internal search retrieval methods, and often it will have other tools like coding tools, um, because it may generate tables, it may generate figures, right? So often you will see it generate a comparison table. So this is actually using some sort of coding or data analytics tools. Um, yeah, so agentic deep research usually requires deep search, right? So it will decide how to search, right? On the left, you see AI2 paper finder, it goes through, it shows you some of the steps. And on the right, you see undermine, it shows you various steps it does. It will search for missing papers, it will iterate and try and so forth. So far I've been talking about large language models, right? It's important to note that semantic search, people use this term broadly, right? And sometimes it might be just using the LLM to generate Boolean, right? But often when we're talking about semantic search in things like JSTOR Beta, which has a semantic search, and Web of Science, which combines Boolean and semantic, the semantic here isn't using large language models. They are actually using vector embeddings, right? I mean, vector embeddings is a very technical thing, but I'll give you a quick overview. It essentially uses transformer-based methods, right? Transformer-based models. So transformer-based models are also used for GPT models. But what they do is that instead of generating words, they generate numbers, right? So you can think of a vector embedding as a series of numbers that encode meaning, right? So usually what you do is that you have a pre-trained embedding model. You run the query as well as the document through an embedding model, and you get a series of numbers. And then you do a comparison matrix between the two, right? Usually you do something like cosine similarity or dot product, and you will produce what we call a similarity score. And this score is used to rank, right? The pros of this method is that if you train the embedding model properly, right, the numbers will encode meaning, right? So you may not even have to write keywords, right? You can still tell that, yeah, this term and this query is kind of related. It works well, right? But what actually happens in real life is that the industry practice is to actually do both normal keyword searching or Boolean searching to generate a set of results, as well as semantic embedding searching to get a set of results, because they have both strengths and weaknesses in different areas, right? So the best way is to actually run both types of queries, of algorithms, combine them together, and then do a re-ranking, right? There are many ways to re-rank, but one popular way is basically to feed it to an LLM, right? Remember we talked about LLMs and re-rankers, right? This is what we were talking about, right? The LLM will take the top 10, will say it will take the top 10,000 results, and then it will rank them, right? So basically you're using a multi-stage ranking system, retrieval system, plus a re-ranker using LLMs. So I've talked very like for 20 minutes about the type of AI search, and how AI is impacting search. But here are three issues, just three. There are many issues, but I'll just focus on three issues to think about using AI-powered search. The first is the search algorithm being used, right, actually impacts the ability of the search engine to generate search counts, right, hit counts, right? So if you use a traditional search engine like Scopus or even Google Scholar or like Web of Science, right? You can get the exact number of matches, right? When you use a Boolean method or even a lexical keyword method, it's very easy for the system, for technical reasons, to show the number of hits, right? So like if you type in the word apple and oranges, you will get maybe 205 documents, right? No more, no less, right? And it's very fast for you to figure out what are the 205 documents have the word apples and oranges, right? But when you do vector embedding, remember the numbers, it's very tricky, right? There are two reasons. First thing is when you're talking about vector embeddings, you get a cosine similarity score. You get a similarity score. So the question is, what score do you consider a hit? Okay, that's one problem. Secondly, even if you decided, okay, let's say anything more than 0.8 is considered a hit, right? For technical reasons that I don't have time to go into, it's very expensive for the system to figure out, okay, which of the 2 million documents have cosine similarity of 0.8 with this query, right? It's extremely expensive, right? A cheaper method is what they call nearest neighbor method, which is they can tell you, for this query, these 100 documents are the closest, right? So it's easier to do this, still slower, right? But possible to do this. Which is why when you see a lot of systems like SciSpace or Elicit, or even when you look at Web of Science, you look at the smart search, you look at the semantic search, they always show like the top 100 or the top 10 or the top 8, right? It's because they are using the top K method, right? They're just showing the top K uh, relevant method, right? It's very expensive for them to say, these are more than 0.8, right? And then you go into AI search systems like agentic search systems like Paperfinder, Undermine, um, and you see it, and then you see a number, right? You see a number like say 232 results, right? And you're wondering like, how come in this case, even though it's AI powered, it can actually show you the exact number of search. But the thing to think about is that in this case, right, when you're talking about deep research tool, right, or deep search tool or agentic search tool, they are actually mimicking the human researcher. So when they show 232, it either means they look through 232 papers, or among the 232 papers that they look through, uh, like maybe 232 are relevant, right? So when you talk about deep search or deep search tool, the number that it shows is not the same as the number shown in the Boolean or keyword search method. And of course, this affects how people search, right? So a lot of people, they like to do keyword search and they look at the number of results to get a sense of how good their query is. But when you talk about top K results or you're talking about deep search results, it's very hard for you to judge whether your query is good or bad. The other thing about shifting from Boolean to semantic search is that it often results in what we call indeterministic or non-reproducible results. What this means is that if you type in the same query twice, you may get different results, right? So this is an example from Scopus AI. I ran the same query twice, just one after another, and you can see that the Boolean it generates is different, right? Which makes sense, right? Because if you use ChatGPT, you will notice that the results are indeterministic, right? If you type in the same query twice, you often get quite different results, right? So when you use large language models in any part of the search pipeline, right? Let's say you use it to generate the Boolean, obviously you run the risk of getting different results, right? And therefore your results are not so reproducible anymore. Even though the index is the same query might give slightly different results. And I've tried this before, right? So I've tried this with Web of Science Research Assistant, Primo Research Assistant, and this happens quite a bit, right? So maybe you try it 5 times, you'll realize that you'll get different results, maybe like once or twice. The other thing is that if you use LLMs to generate, like say a Boolean, at least you kind of understand why the results appear. But if you use vector embeddings for semantic search, the search becomes non-interpretable, right? So in this example, right, you run the search, right, and it gives you a similarity score. The problem here is that you won't be able to know why the score is 0.8. In fact, nobody in the world can tell you what is 0.8, right? So this reduces the interpretability of results, right? Compared to a Boolean search, you know exactly why a result appears or not. But for semantic search, there's no way to know. Lastly, when you use LLMs or large language models, they often have some sort of unknown bias, right? So they may be biased towards, I don't know, genders or things like that. And more importantly, they tend to be fine-tuned to have guardrails, right? So for example, they do not, like for example, OpenAI does not want the LLM to give you like answer questions like how to create biological weapons, for example, right? So they fine-tune it to refuse to answer such questions, right? And if you're using this for search, it gets tricky, right? So I think 2 months ago, there was this big hoo-ha, right? Someone realized that when they use summon to summon research assistant, right, to generate Boolean, there were certain types of queries that it would either error out or show zero results, right? So like sensitive terms like Tulsa race riots or something massacre, right? It would either error, or show zero results. And I investigated this more thoroughly. I tried with things like Primo Research Assistant, and it seems to be particular to just the Clarivate products, some of the Clarivate products. And there's a long series of somewhat sensitive terms that you put in that it tends to give errors or show zero results. And what actually happened is that in this case, Ex Libris was using a platform called Azure, owned by Microsoft. And essentially, Microsoft, when you use their large language models, they have a certain level of content filters, right? Because when you use such systems, you don't want a chatbot to, let's say sensitive things or profanity and things like that, right? So it looked at the query and it thought that some of the queries are too sensitive, and then it refused to generate anything, right? And what XGP did was to try to solve this problem is to reduce the sensitivity, right? So they can't remove this content filter completely, but they can kind of lower it down, and they did lower it down to the lowest level. So right now it is less likely for such things to occur, right? But this gives you an idea of how tricky it is when using large language models, right? So even if you don't use Azure's platform, you use, let's say, OpenAI directly, right? OpenAI, and you do a query about nuclear weapons, right? The LM might somehow subtly refuse to answer or subtly says nothing is relevant, which is even worse, right? In this case, the LM actually kind of told you that, right? It refused to answer. So you know something was up. Right? I think more tricky is the LM some sort of bias, right? And it's not so clearly erroring out, right? And this is something that I think only the person running the system, the vendor would know when the LM is actually hitting some of these guardrails, right? So I think for the end user point of view, you can't actually tell that's happening. Yeah. So again, when we use LMs, people tend to, for search, a lot of the focus is on the performance, right? Does it hallucinate, right? Does it come out with ghost references, right? Is it source faithful? But I think even if and when the performance issue is reduced, is solved, so you get tools that are super accurate, right? They tell you, they can find most of the relevant papers. If you wait for like half an hour, they give you like 99% of relevant papers. Let's say you reach that level, right? The question now becomes in terms of education and learning, right? Like for example, I always ask, do we lose anything if it's just in the future don't know how to enter the right keywords? They don't know how to scheme and understand papers because it all summarizes for them, and or even just writing, they use it to write. Right. So this is another interesting issue that goes beyond just discovery and performance, but more on the learning issue. Right. So that's all I have. Thank you so much for listening in. Right. I'm going to stop the recording.